Today we'll talk about our lab one. So we'll first see what exactly we do in lab, how we do all this programming, low level. So we have a Fox 11 trainer board, which is like a computer. Okay, so I'm passing a board to you so that you can see and take a close look of how it looks like. So as you can see, we have plenty of ICs. This is a digital circuit. We have a breadboard where we build some circuits sometime. So this is called Fox 11 trainer board. So here is our microprocessor. This is actually the microprocessor for which we are writing all these instructions. Okay, this is the microprocessor by the Motorola, and the instruction set that we have and writing all the instructions is actually for that microprocessor, which understands this set of instructions. Okay, and again, even if you have a different microprocessor, let's say you are using an Intel microprocessor, you will still have a similar instruction set. You may have more instructions than the ones that we have right now, but the idea is pretty similar. That's why we use a board which is open for education purpose. Okay. Now, if you see, there are some additional things here. I'm saying switches and connectors and some of the other things that we need to know. For an example, we have a dip switch here that you can see. This is used as one of our port. We'll talk about this detail when we'll be doing the labs. There are two serial connectors at the right side, and these two serial connectors are connected to our computer, okay? Because when you are in the lab, you have to connect this board to your computer. To connect these, we use these two serial connectors. If you go to the lab, you'll see that in every computer you have two serial connectors to connect here, and you also have to power it up, right? So to power it up, you need, we have power adapter which goes here, and there is a small reset key which we press to reset it, just like our computer. You reset it, right? Sometimes, you reset it. So we also have a breadboard here, which you use to build some circuit in some cases. Let's say you have a circuit and you want to drive the circuit using your microprocessor. So you can write the code, and at the same time you can build the circuit here, and then later on you connect this circuit with this. You see these black slots here? You connect it with all of these. But we'll talk about those later on when we will be doing those labs. Now, to understand what we do in the lab, I tried to write a couple of steps. This is what we do. We write, or sometimes we modify the assembly code. I think by now you have seen how the assembly instructions look like, right? We have not written a whole program, but we have idea that how the instructions look like. So we write instructions, we modify them. So we use this microprocessor, the M6800 series microprocessor, the one that we have with this Fox trainer board. In the step 2, we compile this assembly code. Okay, just like your high-level language, what do? You compile it, right? Now, once you compile, a file is generated, which is called srecord file. Okay, the file is called srecord file if your compilation is successful. Then in the step 3, we download this srecord file into the Fox trainer board, because this is what actually happens. When you are working with your programming code, you actually do in your computer, right? Not that board, right? You're actually writing everything in your computer. So when you compile it, the srecord file is actually generated in your computer. In the step 3, you download that srecord file from your computer to this board. This board has the RAM, right? So you are actually downloading that srecord file into this Fox trainer board. Okay? So once it is loaded, meaning your program is loaded here, you can run this downloaded srecord file in this Fox trainer board. And at the end, we see the output in the computer. and we can verify the output, of course. This is actually what you do in every lab in short, but to understand this a little bit more detail, let me show you the steps. So this is how our compiler look like. Okay, this is called ASMIDE. This is actually software where this is like a C++ compiler. This is actually where you write those assembly instructions. Okay, if you go to our lab, you will see that in every computer we should have an ASMIDE icon to work on this environment. So once you click it, you will see a similar window that you can type it some instructions. You can write a program, or you can load a program. You can open a program which is already written, for an example. Okay. Now, so what you have here, so this is the place where you actually write the instruction. Okay. We probably have not written a complete program yet, so we'll talk about this in the lab. We'll try to write this in the lab. So don't worry about the programming at this point. Just see what we have there. So we have a message tab at the bottom, which actually shows the messages when you are compiling or assembling your program, right? Because it's possible that you might have some errors, so you will see those messages here. Okay. If even there is no error, you still see the message like exit code 0. That means there is no error. Okay. So this tab is for messaging, but the next tab here is called terminal tab. Now in the terminal tab, you can type in the instruction. We'll show you how to do it, how to use this one. Okay. So now let's look at more closely how things work. Okay. These are the more detailed steps. At the very first step, we connect our Fox trainer board to our PC. How we connect? Two things. We connect two serial connectors. Remember, there are two serial connectors between our computer, between the PC and that trainer board. We connect those, and we connect the power adapter to the Fox trainer board. So this is the first step, how to connect it to the computer. Step 2, we open the assembler that we have installed in our lab computers. You will see the icon ASMIDE. Click it, it will open up. Then we open an assembly program. So for an example, let's say I gave you an assembly program. Okay, so you will open the program. Let's say probably we'll do some modifications. So every assembly program will have an extension called ASM. Like every file has an extension, right? So the assembly program will have an extension .asm. Then, based on the instructions or the procedure, the lab procedure, you might be writing or modifying some assembly, assembly program. Whatever you are given, you will modify it, or you will add some new code. Step 5, you compile this assembly program. Okay. Now the assembly program means you are compiling the ASM file, right? Now once you compile it, as I said before, an srecord file is generated. Now this srecord file will have an extension called S19. So basically, once you compile it, you will see a file is generated called S19. Remember, this happens only when your program is written correctly and there is no compilation error, meaning assembling error. Okay. And a list file is also generated, which has an extension LST. So basically, there are two files generated if your compilation is successful. Okay, one is with an extension S19, one is with an extension LST. All of these files will have the same file name, only the extension will be different. You know what I'm saying? What about your original file name? You will have the same name for all these files. Only the extension will be different. Your original file will have an extension .asm. If you compile it, it will have two additional files with the same file name but with different extensions. One is S19 and one is with LST. The LST one is called list file. Then step 6, because we know that in the step 6, we know that our compilation went fine. So now we are downloading the srecord file, meaning the S19 file, into the Fox trainer board memory, right? Because we have memories there. And then we go to the terminal window, we type load and press enter in terminal window. Okay. Now, by this typing, we are just telling the assembler to load the S record file into the trainer board. Now we click download. I'll show you the snapshot of all of these. And the step 7, we run the S record file from the SOX trainer board. Okay. And the very last step, we see the output and we verify the output whether everything is showing or displaying properly. Okay. Let me show you some more detail of all these steps. Before I go there, what is the S record file? Meaning the S19 file, because this file seems very important, because this is the file where you will have all the machine code that you are going to load in your trainer board, right? And this is the file which is being read by your microprocessor. So this file is created, this file format is something created by the Motorola. So this extension, and this conveys the binary information in ASCII hex text. Okay. Remember when you did the digital circuit class, you saw that we can write the ASCII in hex, right? We saw the ASCII chart. It's generated by the assembler from the assembly program and transferred to the Fox trainer board when we do the lab. So it's actually commonly used for programming microcontrollers, EROMs, and some other types of programming devices. So, but you probably may not have seen these yet. What is list file? The reason we are just showing these is because we know that there will be 2 separate files created, right? List file is like a plain text file. You can even open this file using Notepad or WordPad. This is just like a text file. Now it contains the object code of the assembly program. Now remember, what is the object code? Remember in the quiz 2 you have learned how to write the object code for the instruction. In this list file you will see the object codes are generated for every single line of instructions that you have in the original ASM file. But now you'll be able to understand the object file because you know how to write the object code, right? For every line you know how to write it. So you'll pretty much see the same things there. So that means the list file is something which you can open using your notepad or using this assembly IDE, meaning ASM IDE, and you will be able to read, I'm saying, if you want. Okay. All right. So let me show you how the step 1 look like. In the step 1, we connect this connector. So there are 2 connectors. We connect them. We also connect the power. Okay. Very simple step. Step 1 is done. The step 2, as I said, we open the assembler. Okay. So we'll find this icon in our desktop. Once we click it, an assembler will open. This will be a blank file. Okay. There is nothing written at this point, right? So you will see there are 2 tabs at the bottom, message tab and terminal tab. If I go to my step 3, we can open an assembly file. So we just go to the file menu and click open and just open an assembly file that is there, or probably you have it in your flash drive. You can just open it from here, just like how you open a file. Let's say we open the file. Okay. Now you will see many interesting things here. All the instructions you write in our in our quizzes, you see the instructions. Those are actually written right after one tab. All the instructions are written after one tab. As you can see, all these blue lines are actually your instructions. And notice the tab spacing before every line of instruction. So you actually have to put a tab for every line of instruction, at least one tab. Okay. And just like the high-level language, we can write plenty of comments. I'm saying, no matter where you want, you can write comments, because we always write comments in our programs just to make sure we understand our program, somebody else understand our program, or we probably recall what we did in future. We can write comments, but every comment start with a semicolon. Okay? You see, anywhere you see semicolon, those are the spaces where we can write comments. Okay? So it's up to you how many comments you want. I'm saying, you can always write your comments. Now, once you are ready with your program, let's say you wrote it or you modified it, what you do is you want to assemble the program, right? To assemble it, what you do is you go here and click build and click assemble. Once you click assemble, you will be able to see some messages under the messages tab. So what messages you have is, it shows you the date and time of the assembling, total number of cycles, errors, and at the end, it shows you the exit code. Now, if the exit code is 0, that means everything is done properly. Okay? That also means that a srecord file, which is S19 file, and a list file, which is an LST file, are already generated under the same folder. Does I'm saying? It doesn't show it here, but if this happens, you will see those two files created under the same folder where you have this file. Okay? So you will automatically have it there if the compilation is successful. Now again, remember, after the compilation is done, both of these files are still located in your computer, right? But you want to load the S1 file into your trainer board. To load it, let's go to the next step. Now, to load it, what we do is we do two small steps. We select download from here and click it under the build menu, and then we actually do this first. We first type in load and press an enter, and then we go to the build menu and select download. We actually type the load first, press and enter, and then we go to the download tab, the build tab, and click download. Okay, this means we are just requesting the assembler to load the S19 file into the trainer board. Once you do that, you will see something like this. You will see some dot lines here. That means that downloading is in progress. It will just take like a couple of seconds, even less, okay? It will be very quick. Once you are done, you know that S19 file is loaded into your trainer board. Now, the next step is you have to run the program, right? Now the program is compiled and is loaded into the trainer board. You want to run it. To run the program, you actually go to the terminal window. Remember, you have a terminal tab. You click the terminal tab, and then you write something like this. This is an instruction, meaning this is not an assembly instruction. But this is an instruction which you type there to tell the assembler to run your program. You just say, okay, GD000. G stands for, a lot of people just think G stands for go. So D000 is a memory location where most of your program starts from D00. So you might be wondering why the program is not starting from 0000. Because at the beginning of your memory locations, we save and store a lot of information. We'll talk about this information later, but most of the programs that we'll do in this class, we actually save it here. So you are actually telling your microprocessor to start reading from this memory location. You see what I'm saying? So, but remember, just for the test purpose, your program can start from different locations, different addresses. All you have to do is just, you have to tell that address here to your microprocessor, just to let it know that where your program is starting. So your microprocessor will start reading from that location. And then once you type it, you press an enter. So it's possible that you might be writing from a different location, so that's why I showed that if your program starts from a different memory location, for an example, if your program starts from 0000, then your instruction to run the program would be G space 0000, and then press an enter. So you can always tell your microprocessor, okay, now I start from this address, I start from that address. You can just tell, and for sure you will know it before, and we'll show you how you will know it in our future labs. Then once you run it, under the terminal window, you will see your output, and then you'll be able to verify whether the output is coming right or not. Okay? So there are several steps, and we need to really understand how things work before we start our lab. So any question at this point? And of course, to understand all these steps, we actually do a pre-lab quiz, which is called pre-lab 1. In the pre-lab 1, we pretty much will ask the similar question that I'm saying, similar questions from this PowerPoint. So basically, how to do this, that, but you can try pre-lab quiz again and again. Okay. The only difference between the pre-lab quiz and our Regular quiz is, in the pre-lab quiz, when you submit the question, you don't see the answer. But you can try it again and again, okay? And the questions do not change much. So you pretty much will have the same question, but if you miss it, you know that answer is here, okay? Let me stop this one as also so that we can go to the quiz section and try our pending quizzes.